Hey folks, just a few quick videos to go. This one will be very short. We've got all the content on the screen. What I want to show you how to do here is forward reasoning, which reminds me of one of my absolute favorite jokes. Um, you ever wonder why when people go scuba diving, they fall backwards out of the boat? Well, it's because if they fell forwards, they'd still be in the boat. So, what's forward reasoning? Forward reasoning is when you reason forward in your context rather than backwards in your goal. Those of you who've done more advanced math, say taken the analysis course here, will recognize that forward reasoning is the preferred mathematical form of reasoning. People don't like backwards reasoning. I don't particularly know why. I have some theories. I think backward reasoning can be harder if you aren't don't know what you're doing. But to me, they're equally good. So I don't really see what the kerfuffle's about. But you should know that forward reasoning is the norm in mathematical communities, whereas forward and backward reasoning are used freely in computer science. Cock makes backwards reasoning easier, but occasionally forward reasoning is the fastest way to do what you want. Let's see what I mean. The gist of it is a lot of tactics have an in form, where you say that tactic and you say where you'd like to do it. Okay, so let's see an example of that in action. So here's something that says if the successor of n and the successor of m gives us some result b, then so does just evaluating EQB for n and m. So let n, m, and b be given. I want to note here that by writing just b, we're sort of covering both the true and false cases. We're saying these two have the same result. Okay. So how will this work? Well, we'll just say, hey, could you please simplify in h? That's cool. Normally, it's just worked on our goal, but this time, worked on our hypothesis. Now, to be clear, we could have done this a different way. We could have said, oh, intro is NMB, and then just simple, and it would simplify in that whole implication, simplify all of the terms it sees everywhere here, right? Nothing wrong with that. We've done stuff like that before. Sometimes this is easiest, right? You're not sort of delaying in intros and having two different intros. You come across something that needs to be evaluated in your context, so you decide to do it. Okay, so simple can do that. You can also do it for a host of other tactics. You can do it for rewrite, you can do it for apply, you can do it for symmetry. Uh, there's some tactics where that doesn't make sense, like destruct doesn't happen in anywhere. Injection and discriminate don't happen in anywhere. Interest really only works on your goal. Reflexivity only works on your goal. But all of these tactics that are sort of manipulating tactics, simple, apply, rewrite, symmetry, things like that, these can all be done sort of freely in your goal. So here's another example that we can see. Um, so using apply, this is extremely silly, right? So if it is the case for some natural number n that n being equal to 5 is true implies that successor of n being equal to 7 is true, which happens to be true for all natural numbers n. I think we've proved it before. Then if it's the case that true EQB n5, right? If those are equal, then EQB S of n 7. What this silly theorem is meant to demonstrate is a situation where, like, okay, you have the facts you want, but things are a little backwards in some spots. Like you have some rearrangement you need to do, um, and you're just not in a great position to do it. So you could already do this. You could do symmetry on your goal, and then you apply this. We have the tools to do all this in a backwards manner. Let's see how it looks in a forwards manner, staying in the boat, as it were. Okay, so what I'm going to do is I'd like to apply EQ here, but the problem is that the sides are swapped, right? Here we have EQBN5, here we have true equals EQBN5, so they're switched around. So by doing symmetry in H flips. Okay, now I can apply EQ and H because the premise matches the hypothesis. So this is the key thing for forward reasoning. Backwards reasoning, you match the conclusion of your implication with your goal, and then you get subgoals for each premise, right? Forward reasoning, you match the first thing of your implication with the thing you're applying it in, and then you'll get this as what's left. So watch, what we're going to get here when we apply EQ and H is we're going to get this as a fact. That'll be what H turns into. Right? Do you see how we basically moved H along the arrow? So H was the thing to the left of the arrow, and then by applying that arrow in H, we get the thing on the right of the arrow. That's forward reasoning. Okay, and now we're almost done. We can almost work on our goal. There's two things we could do. We could symmetry our goal and then apply H, or we could symmetry H and then apply H. Which you do is up to you. I like this proof script for this. It feels sort of fairly natural to me. Working in the context like that. A good exercise, if you're working to practice these tactics, is trying to convert it to backwards reasoning, working mostly on the goal. Up to you. Have fun with it. So I just wanted to make you aware of these tactics. My suggestion is to play with them. There are some times where this is the much easier way to go, and there's sometimes where spending all your time working on the context is less useful than working on your goal. It's a question of judgment, and as usual, the solution there is practice to hone your judgment. All right, that's it for this one. Talk to y'all soon.